Good afternoon. My name is Manan Shukla, and today I'll be presenting about the Fermi paradox. So when you look up and you're laying down on the grass and you look up into the night sky, what do you see? What you see is a countless amount of stars in what we call the universe. So when you look up at these stars, what you would see is, and you would ask them questions. So that is, how big is the universe? And you would answer by saying it's considerably big. And in this huge universe, what is the probability that we get an Earth-like planet that is more advanced than we are? What is the probability of this Earth-like planet can be as intelligent as we are? Or it can host life, can become a life-supporting civilization? And finally, the most main question, are we alone? In the sea of the universe and to the countless amount of stars that we have, are we alone as the only intelligent species out there? Welcome to the Fermi's paradox. What we answer is the question, where is everybody? Are we the only intelligent civilization out there? So we're going to start with some statistics or some numbers. Remember that all of this is going to be based on scientific consensus. We don't know for exactly what these numbers actually are, but based on what multiple scientists have said, this is the numbers that we've come up with. So there are about as many stars in the Milky Way as there are galaxies in the universe, which allows us to think that there are 10 to the 22nd to 10 to the 24th amount of stars in the entire universe. That can equal to about 10,000 stars for every grain of sand on every single beach that we have on Earth. And out of this 10 to the 22nd, 10 to the 24th amount of stars, we have the probability that these stars are sun-like, which is as hot as our sun, the same size, the same amount of energy produced, same amount of radiation created. So that is about 5% to 22% of all the stars out of the 10 to 22nd to 10 to 24th stars. And we're going to assume the smaller number, 10 to 22nd. And what we get is that we have 500 billion sun-like stars. Stars are similar to our sun with the same age, same size, etc. And out of these 500 billion sun-like stars, what is the probability that they have an Earth-like habitable planet? So with the same type of weather, same amount of oxygen level, same amount of carbon dioxide, same size, etc. And that is about 22% to 55% of all these habitable, all of these sun-like stars, which have Earth-like planets. That equals to 100 billion Earth-like planets in this entire universe. So let's assume, based on scientific consensus once again, that 1% of this huge amount of stars would be the chance that each of these habitable Earth-like planets can develop life. And 1% of that is the chance that this life that is formed has the same amount of intelligence as we have. Same IQ, same intelligence level, same amount of technology, etc. That will lead us to 100 quadrillion intelligent civilizations with Earth-like planets in the observable universe. Scale it down to our galaxy, and then we have 100,000 intelligent civilizations in our galaxy. In the entire Milky Way, we have as many as 100,000 Earth-like planets. So people who have the same amount of technology as we do, people who have the same amount of intelligence as we have, etc. And what we have, so let's switch our focus over here, and let's look at SETI satellite array. And that is a type of satellite that NASA uses to be able to find intelligent or alien civilizations in the entire galaxy. We send all types of signals from gamma to infrared rays to see if any civilization is able to pick it up. And it allows us to see whether any other alien is out there trying to look for us as well. The mystery is, we have not picked up a single signal from any alien, any extraterrestrial or civilization since today and any time into the past. Where is everybody? It gets even stranger. So let's look at our sun. Our sun is pretty young compared to many other stars in the galaxy or the universe. We're up over here while we have such a long way to go in terms of billions of years. So let's take an example of a planet, planet X. So planet X is 8 billion years old. We are 4.54 billion years old. Planet X is 8 billion years old. So in this timeline over here, we have the Big Bang Theory, which is how the universe is created. Then we have planet X, which is now born. And about 3 billion years later, we have Earth. Earth is born, and now we carry this on to present day. So let's look at, so let's suppose that planet X's lifespan is about the same as our Earth. So the planet X's story is the same as Earth for 4.54 billion years. And then the next of the rest of the 3.46 billion years is development in planet X. Planet X is 3.46 billion years more advanced than we are, which makes it, so to just put this into an analogy, 10,000 years ago, we were barely even humans. We could only use sticks and stones to create, to prosper, or to even start the Neolithic revolution. This civilization is 3.46 billion years. And just to see how advanced and how more advanced than we are is planet X astounds us, or astounds me at least. So let's put this into a scale. So planet X can be divided into 3 types of civilization. Type 1 civilization is what we are at right now. Type 1 civilization harnesses all the energy of one planet. We are currently 0.7, so we use 0.7 of all the possible potential energy that Earth can possibly create. Then we have type 2 civilizations, which can use all the energy in the entire solar system. How they do this, we do not know. But they're able to use the energy of our star, energy of the rest of the planets that revolve around the sun. And type 3 civilization would be something that we call godlike. This godlike civilization can control energy from the entire galaxy. All of the Milky Way can create, all of the energy that is created by the Milky Way galaxy can be used for the use of one planet. How they do this, once again, we do not know. So let's talk about planet X once again. If planet X has the same amount of technology as we do, which we always know that they don't, and they do not travel the speed of light as we would expect them to do, it would take them 3.75 million years for them to colonize the entire galaxy. 3.75 million years. And that would be a blink of an eye for planet X. It would be a blink of an eye for the entire universe. Once again, if we had planet X trying to colonize the entire galaxy, and it takes them almost no time when we're making it relative to the rest of billions of years of planet X's life, we still have not gotten any signal from Earth, from any advanced civilization out there. We have not gotten any signal, any sort of trace as to where these aliens actually are. And once again, we're at the tangent. Where is everybody? And this argument, this paradox, the Fermi's paradox, has been argued and debated for a long time by various scientists. So what the most common theory, or the common solution to this, is the Great Filter. So what it is a type of filter that makes it extremely unlikely for a species to attain type 3 designation. So what we have is like a strainer. So each species in the galaxy would try to go through, which would be a jump in advancement. And what we have in the last part is the Great Filter, which is the hardest way we can get to type 3 civilization. So once we pass the Great Filter, we are on our way to become a type 3 civilization. And there are 3 theories that come up from this. First of all, that we are rare. We are with another species who have passed the Great Filter, and we are on our way to become a type 3 civilization. Secondly, we are the first. We are the first civilization, or intelligent civilization, to reach type 3 designation. No, we have already passed the Great Filter a long time ago, and we are about to become the dominant civilization in the galaxy. And the type 3 civilization is the unfortunate one, that we are screwed. The Great Filter is in front of us, and we do not know what's going to be of the Great Filter. The most likely scenario is that we will be extinct. due to the fact that the great filter is extremely hard for us to get through, but we do not know yet. So what does that mean to us? So what happens is that due to the general consensus of the Drake equations, we can find that we can attain the fact that we are the first planet or the first civilization to become a type 3 species. That is because of the fact that we cannot get any signal from any other civilization, which allows us to refer to the fact that they're not as advanced as we are. So what can we infer from the fact that we're the first planet to become an intelligent civilization is the fact that the great filter might be behind us, which means that it could have been the jump from prokaryote to a eukaryote, or it can be a jump from hunting and gathering to using agriculture during the Neolithic Revolution. And for us, that means that it's up to us to preserve our Earth for the future of mankind. If we are the only intelligent civilization in this entire universe, with countless amount of stars, as we have seen through our statistics, it is up to us as the only intelligent species to maintain our Earth and maintain the environment around us so that many generations in the future is able to view the beautiful Earth. And not only that, it allows us to pursue human curiosity, to see what really got us here. What is the beginning of human nature? And I conclude once again, we must protect and maintain our Earth to preserve it for our next generation. Thank you.